Dear students, I hope all of you are well. I know many of you are going through great stress because of the board examinations. And your class 12th has taken a very long time. And so maybe you would have forgotten something and you would have revised a lot and still you may be forgetting so much. But my only suggestion is do not worry. Do not fear. Be confident. Be bold. Whatever is that, when you give your best, the result will be automatically best. It is natural for us to sometimes forget something, and it is natural for us to become stressed also. But too much of stress will put you in a lot of more pressures. So do not worry so much. Now when I come to the chapter AC circuits, I wanted to make a point very clear with you, right? AC circuits. Since this chapter consists of a lot of mathematical ideas, so the biology children might feel somewhat it is difficult. What I want to say is it is really not difficult. And if you do not believe my word, okay, no problem. It only will have questions worth 3 marks actually, right? Even if you leave this topic, nothing will happen. Why? Because when you get a 5-mark question, you will have a AC circuits question or transformer. Because transformer comes in this chapter. Let me off the fan, I have forgotten. Yeah. Because the transformer comes in this chapter only. So do not take too much strain. There may be a small problem. I will try to do simple problems which had come in the board examination. Very easily you can solve it. Just 1 plus 1 is equal to 2. Only that type of problems are there. So you need to understand the concept, right? And if you find it difficult, send message to me. I will somehow help you. And do not worry for this 3 marks, because 67 marks is in your hand. Okay, in 67 when you get 65 and practical you got a very good mark, let us say 30, still you will touch 95. In practical even you get 27, 28, any number you take, they all will be more than 90. Yes, keep that confidence in your mind and keep that faith in you, and then prepare slowly and steadily, revise each chapter. I am sure you all will succeed well. The coronavirus has come and disrupted. It's okay, our thought process has changed. Now we are all shooting as teachers, videos. 35 years I am teaching. I never ever thought that I will have a YouTube channel and I will make videos. The videos are spreading throughout all the places, south, west, east and north. Okay, so this is a grand opportunity for all of us to know. You will get the best teachers from different places. See their videos, watch their videos. You want to see something in Hindi, watch that, nothing wrong. Yes, you have now multiple teachers, so you should be more confident. With that, I am going to start Phasor diagram. Okay, now let me erase this part now first. Okay, let me teach you about Phasor diagram. See, what is Phasor? Phasor diagram. See, the Phasor diagram is a vectorial representation. It is a vector. Okay, vectorial representation of potential difference or voltage and current. We are going to express them in the potential difference and current in terms of vector. And it is also rotating vector because it is changing for 360 degree, fine. So the vector is going to now rotate and make different angle, because what is happening here, the potential difference according to the AC generator, the applied voltage V is equal to V naught sine omega t, where omega is angular frequency given by the formula 2 pi nu, where nu is the frequency, actual frequency. Okay, so they are all consist of 360 degree, or you can say 2 pi. Yes, keep this in mind when you talk about phasor. phasor or phase. Okay, this phase, this is to do with the angle. Okay, let me now first explain. Let us take only resistance circuit. Only resistance circuit. In only resistance circuit, what is going to happen? Current is equal to voltage upon resistance. Sin omega t can't cancel. So we say both of them are in same phase, right? So I am going to draw a vector diagram. Okay, let me see how best I can draw a diagram for this. Okay, now let me draw x-axis and y-axis. X-axis and then y-axis. They are all based on time. They are going to have time as the factor. Now here I am going to have potential difference and also I am going to have current. Now I will draw a single straight line like this. This arrow mark with this represents V0 sin omega t. This arrow mark, the vector, represents V0 sin omega t. What does the tip says? Tip says this is the maximum value of V0. Right? And what is the angle here? See, this angle is rotating, na? This is going to be 360 degree and this angle is actually omega t. The omega t is the variable and that is the angle here, and this is the phasor diagram, which is an arrow, which is a vector quantity, which is V0 sin omega t. Now next step, I want to express current. You know that in only resistor, they both are in same phase. So when they are in same phase, what I do? I just take, I don't have a color chalk piece, so let me take another one like this, right? Little bit thick, okay? And this represents I0 sin omega t. And what is the tip again represents? The peak value I0. So in the same thing we represent current as well as the voltage. Watch carefully, dear students, right? This is the x-axis, time axis, and this is going to be the potential difference. Potential difference is going on moving, right? 360 degree, current is moving. Now what is happening here? The potential difference and current are in same phase. So they both represent, merge in the same line, and this is the phasor diagram for only resistance. Okay, you understand what I am saying? Yeah. Now let us take only inductor. You should be very clear about the concept. Only L or inductor. When it is only L, I also said that the reactive inductance XL is equal to omega L. And you remember that in this we say that current lags voltage by how much? Pi by 2 or 90 degree. It is lagging, right? So now that's all. The same diagram. We are going to have the same diagram. Nothing. Phasor diagram is really nothing. Yeah, the board is getting little white. I am not happy with this actually. What is happening? Yeah. Okay. When it is white, actually what is happening? You cannot see it clear. So let me just erase it much more carefully. Yeah. See here. Now I take again y-axis here. Little take it up here. This is time axis. Now this is going to be voltage is going to be there. It will represent same current also. This is the origin. We will always fix the voltage. We will fix the potential difference. Oh my God. Yeah. Potential difference. Now this represents, as I said to you before, V0, the peak value, and this arrow represents V0 sin omega t. What is this angle? This angle, rotating angle, omega t. Now, we say that current lags voltage by pi by 2. See, current lagging, negative. So, current is going to be represented here. And I am taking current with less amplitude. Okay. Now, I will draw here another line and I will say that this is I0 sin omega t, where this is going to be the peak value I0. But you may wonder, how did I draw? I didn't draw here. I didn't draw here. I drew it exactly 90 degrees so that I satisfy the condition that voltage and current, they lag by how much? pi by 2. You see here voltage is already going forward. So this is the forward direction rotating vector. This is how it is going to be. But what is happening? It is coming behind it. So when something comes behind it, it is lagging. It lags something. What it lags? It lags an angle of pi by 2. I hope you understand what I am saying. All these phasor diagrams, potential difference and current, all these are vectors, and these vectors are rotating. So that is what is the most important point. Okay, now let me erase this. Okay, now keep this in mind, one thing very clearly, that how much angle is it lagging. Okay, that is bilkul, it's going to be exactly 90 degree, or you can express it as pi by 2. It doesn't matter. Now let us come to only capacitor. Okay, only capacitor. In capacitor, XC is the capacitive reactance. Now reactance is what you use it for resistor in AC circuit. Now 1 upon omega C. 1 upon omega C. Here current leads going ahead. Current is going ahead. We drew it graph, but here I am going to draw in the case of vector diagram, and this vector diagram is also referred to as phasor diagram. Yeah, this I will just draw again. You see, yes, this is time again, and origin. Let me fix the voltage point, right? This is V naught sine omega t. This is the angle omega t, which is rotating, fine, and this is the peak value V naught. Yes, here look at the statement, current leads. So where is the current? Current is going to lead. It is going to lead here. It is going to come ahead because it is coming. It is already moved ahead. But I have a smaller to differentiate. Okay, to differentiate between this and this, I have taken a smaller amplitude I naught, and you can very easily see that the angle here is 90 degree. So this is leading. It is going ahead and this is coming back. Okay, so this is what is the meaning of current leads voltage by pi by 2. And I hope you understand this concept. Today I am going to do one or two numerical to give you confidence, right? So let me take the NCERT textbook. Dear students, when you practice at the end time, use NCERT textbook. Okay, that's quick for you to do revision, and particularly AC circuit is dealt with beautifully in this book. Okay, I have marked the pages, okay, with my paper. One is okay, I have to erase this board. Yeah, let me erase the board. Yes. Okay. Now, let us come to this point here. Page number 236. This is example 7.1. Do the examples and do the basic numericals and then go for additional if time permits. It says a light bulb is rated at 100 watts for 220 volt supply. 100 watts. What is that? Power. Voltage is equal to 220 volt. This is actually, keep it in mind, RMS value 222, root mean square value. Now he is asking you, find the resistance of the bulb. First point, find the resistance of the bulb. And then he is asking you to find the peak value. V naught is equal to how much? This is, I think, very easy. We know that V RMS is equal to V naught upon root 2. So V naught is equal to root 2 times V RMS. Okay, so root 2 multiplied by 220. I am leaving this part for you to solve it. because it will take hell of time for me to do in this video. So you can solve it. The book answer is 311 volt. Now second is that resistance, and third one is again current. We have to calculate the current. How will you calculate the current? First let us find the resistance. How will you calculate resistance? You remember all of them are in parallel. So you take the formula P is equal to V square upon R. Very rarely I squared R will be used, that is used only in series circuit. Otherwise we prefer V square upon R because voltage is constant. So what voltage you have to take? RMS voltage. 220 square divided by resistance we need to calculate. Okay. So this power will come here. What is the power here? It is given 100. Okay. That is equal to 220 multiplied by 220 divided by 100. 0, 0, 0, 0, 22, 20. I think it is 484. 484 ohms. Dear students, you please write it and solve it in the side. That will be better for you. Yeah. And we need to calculate I. How will I calculate I? I have VRMS and I have power. So power is equal to V into I. That is VRMS value is 220. Oh my God, just wait 1 minute. So I is equal to P upon V. P upon V. Power is 110 divided by 100 upon 220. 0, 0 goes 10 upon 22. 11 upon 22 is half, right? So answer here is 0.45. So that is a cross check ampere which I have taken from the book directly. Why I am rushing like this? I want to do another problem which is also, I want to do as many problems as possible so that you are confident of writing in the exam. Okay. Now I am coming directly to example 7.4 which is in page number 242. Remember, CBSE will not ask very complicated numbers, right? Numbers will be easily solvable. So you don't need calculator or need to do anything at all. Okay. Whereas in ICSE or ISC they use calculator. You don't need, because the numericals which are given by CBSE, you can check all the 10 years or 20 years book question papers, they are all easily cancelable, because what they want to check is your concept. They want to check your understanding. They want to check your application, right? That is why do not fear about numbers. Numbers are usually easily cancelable, right? So let me try to do this problem which requires more clear picture of for you. Okay. Now I am going to write the data. What is given, I call it as a data and I write the data. Here 15.0 microfarad. What is that? Capacitance, right? Microfarad means capacitor is connected to a 220 volt, that is potential difference. 50 hertz, that is 50 hertz is frequency. Whenever you know this, I will suggest you, so we use actually nu. Okay, omega is equal to 2 pi nu. That is equal to 2 into 3.14 into nu is 50. 50 into 2 is 100. So 3.14 into 100, it is nothing but 314 radian per second. Remember, this is going to be angular frequency. So it should come in radian. Fine. Now he is asking you, find the capacitive reactance. Xc is equal to how much? That is 1 upon omega c. That is equal to 1 upon omega I calculated. 314 into capacitance is, remember, whenever you get microfarad, picofarad or any other thing, you go for the conversion immediately. 10 power minus 6 farad. That is micro, that is 10 power minus 6. Nano 10 power minus 9, pico 10 power minus 12, milli 10 power minus 3, all in less than value. Okay. Now, into capacitance how much? 15.0, don't worry, that is only for accuracy, 10 power 6. 10 power minus 6. So 10 power minus 6 will go up, and 314 multiplied by 15. Dear students, you solve it yourself and find the answer. Now I am going to check the book and I am going to write the answer for you. 212 ohms. So what is the unit of reactance? Ohm. Why is it ohm? Resistance is ohm in DC circuit. So reactance is similar to the resistance only. It is a AC resistance. So unit is ultimately ohms. Yes. Our next question is calculate the current. Okay. Now what we have to do? This I told you, keep it in mind, write it with pencil, small RMS. He is asking you V0 is equal to how much? Root 2 times V RMS. Okay, that is equal to 1.414 multiplied by 220. That is equal to, I think, 311 volt. Just let me check it once again, my friends. Yeah. My God, where is it? Yeah, this is 311 volts. But what is he asking you? Calculate the peak current. Okay, this is peak voltage. This also will be correct because 220 it will come. I0 is equal to I. Where is I actually? That we find? No. So first we have to calculate I. I is equal to V by R. V we know, that is 220 divided by, what is R? This value, that is 212, and that will give you the value of this, that is given to be 1.0404 ohms. I hope you understand this point. Yeah, first you calculate this. From here, this is again what? RMS value, because I substituted RMS value and this is also RMS value. So I0 is equal to root 2 times I RMS value, which is equal to 1.414 into, I got here 1.04, it should be 1.5 or something like that. Yeah, 1.47 ohms. Yes, I have done the second part. Now, what we have to calculate is, yes, let me go back to the page here. Yes, dear students, now I am going to solve a conceptual idea for you. Once you understand it, there will be classic. Yeah, shall I erase all these things now? Okay. The technology has changed the way in which we look at education now. And the coronavirus and COVID with first phase, second phase and second, third and all this stuff, we have become more techno savvy. I hope you also are using all the technology for the better understanding of your subject. When you are with the mobile, that is actually called quality screen time. As long as you use the mobile for quality purposes, watching educational videos, it's nothing wrong at this point of time. Yes, don't get addicted to it. Now, this is a social message, okay? You may think, yeah, what is this? A physics teacher is going to telling all this stuff. No, you also should have certain values to be imbibed. Too much of holding the thing, eyes will get affected, right? And also what will happen, your mind, the light coming from there, that is actually blue color light, and that blue color light hurts the eyes too much. And particularly in night time, 9 o'clock, 10 o'clock, when you go and the whole every surrounding is dark and that light intensity is exactly focused on our eyes. So please avoid using it. Okay, too much late night. Okay, do not take stress, right? Everything you write it and practice. Now, I'm going directly here. XL is equal to omega L and XC is equal to 1 upon omega C. Here we are talking about this formula presently, right? He says now, if the frequency is doubled, if I increase the frequency, I know that omega is equal to 2 pi nu. If I double it, what will happen? That means the denominator is doubled, and then this will become less and it will become halved. It will become halved. When you double it, in the denominator and this will become halved. What is this actually? Reactance, capacitive reactance. What is that? Resistance. Current is equal to voltage upon resistance. For AC circuit, voltage upon XC. So when this is halved, when you halve the denominator, current will be doubled. So frequency is doubled. Then remember, the reactance will be halved. When reactance is halved, current will be doubled. Try the same thing with inductor. In the next class, I will come with LCR circuit. And then I will do the same thing and then we will go for numericals. Dear students, again you may get problems on LR circuit and CR circuit. They usually won't ask you derivation. They don't think that every time they will ask you derivation. Yeah, this AC circuit is more applicative and they will ask you numericals and some conceptual questions. You understand that maybe it may come in 1 mark, it can come in 2 mark, it can come in 3 mark, so that you will be able to solve it easily, right? And I want to end this video, yes, with a small point. Yeah, maybe look at here. I am teaching physics for 35 years. Before coming to shoot this video, first and foremost I wrote everything. Phasor diagram, resistance, and then inductor, then I did capacitor, and then I did a numerical. Because in the comment section I saw numerical, so I have solved a numerical. So this is how we do it, you know. You have to write it and practice it, and then your memory. 1 time writing is equal to 10 times reading. I wish you all the best for your board exams. Thank you.